Packet tracer configuring basic EIGRP with IPv4. Now first is objective configure EIGRP and verify EIGRP routing. Now in this activity you will implement basic EIGRP configuration including network command, passive interface, and disabling auto summaries. You will then verify EIGRP configuration using a variety of show commands and testing um, end-to-end connectivity. While we do all those steps such as configuring EIGRP, enabling EIGRP routing process, um, advertise directly connected networks, and configure passive interface, disable automatic summaries, we're going to be going over a brief overview of each of the features. I will discuss neighbor adjacency, passive interface, and directly connected networks, and EIGRP command. Um, First, enable EIGRP routing process. Enable EIGRP routing process on each router using autonomous system number 1. The configurations of R1 is shown. So let's go to the R1. We go command line and we type enable config t, and then we type router EIGRP 1. Now EIGRP is enable. Now what is the range of numbers that can be used as a autonomous system number? The range of number is 1 to 65,535. Multiple autonomous system number is same as process ID number. It is used to track multiple running instances of EIGRP to support updates, routing exchange of different network. More than one instance of EIGRP may run. Now each autonomous system number is significant to whether there is each autonomous system number is significant to route packets within their own routing domain. So it functions as a process ID to help routers keep track of multiple running instances of EIGRP. It is required because it is possible to have more than one instance of EIGRP running on a network. Each instance of EIGRP can be configured to support an exchange. Can be configured to support exchange routing updates for different networks. Now, Cisco I operating system, it includes the process to enable and configure several different types of dynamic routing protocols. The router, this command, the router in a global configuration mode, and it is used to begin the configurations of any dynamic routing protocol. So EIGRP is a dynamic routing protocols, and to initiate EIGRP, we use this router command. Now in these pictures, you see that the router EIGRP, the EIGRP process on router R1, R2, and R3, and notice that the prompt has changed to uh, from global configuration mode to router configuration mode. See that once this is a global configuration mode, when we see use router EIGRP1, it changes to router configuration mode. Now, advertise directly connected networks. We use show IP route command to display directly connected networks on each router. Now, how can you tell the difference between subnet address and interface address? We use show IP route command. Now we use show IP route command. Show IP route, and now we see these are the all directly connected network. These are all directly connected network. The C stands for network address, and L is the local host, which is the interface address. And the one thing that is common is they are all directly connected network. Now, on each router, configure EIGRP to advertise specific directly connected subnet. This the configuration for R1 is shown. So this is the R1, and we're going to be configuring R1 EIGRP to advertise this specific directly connected subnet. So we go to the global configuration mode, config T, and we type router EIGRP1, and we type network. Network is 172.16.1.0. 172.16.1.0. The gigabit interface address is 172.16.2.1, and the network address is going to be 172.16.2.0. 172.16.2.0, and then wildcard mask is going to be 0.0.0.255. 0.0.0.255, because we subtracted from 255, 255, 255, 255. So we subtracted this 255, 255, 0 from 255, 255, 255, 255, and the remainder is this is the wildcard mask 0.0.0.255. And now we use the second subnet address. We type network 172.16.3.172.16.3. Serial interface address is 3.2. So the subnet address is going to be 3.0. 3.0, and wildcard mask is going to be 0.0.0.3. And then third interface is serial 1, which is 192 The interface address 192.168.10.9. So the network is going to be 192.168.10. Dot. So this is the 10.9 is um, 10.9 is the interface address. So the network address is going to be 10.4, and 0.0.0.3 is going to be wildcard mask. Now configure passive interface. Configure the LAN interface to not advertise the EIGRP updates. The configuration so far one is shown. Um, we configure passive interface, and the router configuration mode we type passive interface. Um, we're going to be making gigabit 0/0 is the passive interface. Uh, this is the one. This is the one is going to be the passive interface. Now, what is passive interface? So this when you configure EIGRP, we are in the router. We have it. Um, EIGRP is router in EIGRP is enabled, and when you configure EIGRP using broad networks such as 172.16, 2.0, 0.0.0.255, any interface you bring online with an IP address that falls in that range will start advertising and processing um, hello packets on that interface. Uh, in some situations, you may want to disable EIGRP from sending and receiving hellos packets on a particular interface. However, you may still need that interface, that network, which the interface is connected to, be advertised through the routing domain. Now, a great example of this would be to disabling EIGRP hellos on a link that goes from a distribution switch to a layer 2 access switch. Another great example would be a network handoff link to a third-party organizations which you have no control over. And in this case, you would need to advertise that particular link throughout your own routed domain, but not allow the third party to receive hellos or send hellos to your device. Now in this picture, you can see that R1, R2, and R3, they don't have any, in this topology, they don't have any neighbor on their gigabit Ethernet ports. This is, you see, you don't have any neighbor. You don't have any neighbor in the topology. You don't have any neighbor in the topology. In this picture, you can see that passive interface command in a global configuration mode, in the router configuration mode, and passive interface is used in gigabit 0 Ethernet to suppress hello packets on the LAN. Now, without a network adjacency, EIG cannot exchange routes with a neighbor. So the passive interface command uh, prevents the exchange of route on the interface. Although EIGRP does not send or receive routing updates on an interface configured with passive interface command, it still includes the address of the interface in routing update sent out of other non-passive interface. An example of using passive interface to increase security control is when a network must connect a third-party organization for which the local administrator has no control, such as when connecting to an ISP network. In this scenario, the local network administrator would need to advertise the interface link through their own network, but would not want the third-party organization to receive or send routing updates to the local routing device. And this is because this is a security. This is a security risk. And now this picture verify that passive interface. Um, Use the show IP protocol in the privileged executive mode commands. You see that um, R3's gigabit Ethernet 0/0 interface is passive. Gigabit 0/0 interface is passive. Um, EIGRP still includes interface is network address, which is 192.168.1.0. This is the network address in the routing update. Now we use disable automatic summarizations. The topology contain this contiguous network. Therefore, disable automatic summarization on each router. So what is the topology? This is the topology, and it contains this contiguous router. You see this this gigabit ports. This gigabit port it has an address of 172.168.1.0, and this is 172.168.3.0, and this is 192.168.10.4. So all these three networks are different. They're not in the same network. So when you have a router that has different networks, more than two, this is called a um, contiguous um, This is a contiguous network, and it is for the best to minimize the router's resources, because every time they try to auto summarize, it consumes the router resources. So we don't want that in a contiguous network. So we disable auto summarization using no um, AUTO with tab completion. You see the auto summary, no auto summary. This disable the auto summarizations. Auto summarization helps reduce the size of routing tables. So we don't need that at this point. Now we save the configurations. Copy. We go to the privilege executive mode. Copy. Uh, Copy. Run. Start. So we copy the running configuration to startup configurations. Now we do the same configurations on in the topology on the other router. So we did only router R1. Now we got to do router R2 and then router R3. So this is the router R2. I go to the R2. enable config t. We did type router EIGRP 1. We type network. So gigabit Ethernet is the address on the gigabit Ethernet is 172.16.2.1. So the network is 2.0. 172.16.2.0. Dot 16.2.0, and wildcard mask is going to be 0.0.0.255 dot 0.0.255, and the second address is 172.16.3.2. So then the network is going to be 3.0. Type network 172.16.3.0 0.0.0.3. We see we have the neighborhood adjacency with the next with the router R1. And now this is the third one, 192.168.10.9. That's the 192.168.10.9 is the interface address. So the network address is going to be 192.168.10.8. 192.168.10.8 and 0.0.0.3. 0.0.3. Uh, 0.0.0.3. Network 192.168.10.8. Oh, we put an extra 0 here. So network 192.168.10.8 0.0.0.3. Now we disable we configure passive interface. Passive interface gigabit 0/0. This is the port that we're making passive interface gigabit 0/0. And you do no auto summary and end copy run start. Now we do that in R3. We go to the R3. Enable config t router EIGRP 1, which is the same process number or no system number. Now we're in the router configuration mode. These are the interface that we need to configure. We type network 192.168.1.0. 192.168.1.0 and then 0.0.0.255. 0.0.0.255, and then the second one is 192.168.10.6 is the interface address. So 10.4 is going to be the network address. So we advertise network 192.168.10.4. 192.168.10.4, and wildcard mask is going to be 0.0.0.3. We see that the neighborhood neighbor adjacency message. And now this is the third one. 192.168, 10.10. So the address is going to be 192.168.10.8. Network 192.168.10.8 and 0.0.0.3. So advertise we advertise all those networks, and then we copy, run, start. Uh, Now part 2, examine neighbor adjacencies. Um, Neighbor adjacencies. Now the goal of any dynamic routing protocol such as EIGRP, what is their goal? Their goal is to learn about remote networks from other routers and reach convergence in the routing domain. Now, before any EIGRP update packets can be exchanged between routers, EIGRP must first discover its neighbor. EIGRP neighbors are other routers running EIGRP on directly connected networks. This EIGRP uses hello packets to establish and maintain neighbor adjacencies. For two EIGRP routes to become neighbors, several parameters between these two routers must match. For example, EIGRP routers must use the same EIGRP metric parameters, and both must be configured using the same autonomous system number. Uh, Now let's examine this picture. This picture shows two EIGRP routes exchanging initial EIGRP hello packet. Now, when an EIGRP enabled router receives a hello packet on an interface, it adds that router to its neighbor table. We see the first, a new router, which is R1, comes up on the link and sends the EIGRP hello packets through on its EIGRP configure interface. Here's all my routing information. It sends a hello, I'm a router R1. Is anyone there? And then now router R2 receives the hello packets on EIGRP enabled interface, and R2 replies with an EIGRP update packet that contains all the route it has in its routing table except those learned to the interface, which is split horizon. However, the neighbor adjacency is not established until R2 sends an EIGRP hello packets to R1. Here you see that the after both routes have um, it sends the hello packets here, and then after both routers have exchanged hello packets, the neighbor adjacency is established. R1 and R2 updates their EIGRP neighbor table, adding the adjacent route in as a neighbor. So examine neighbor adjacencies. Um, which command displays the neighbor discovery by EIGRP? Uh, we use show IP EIGRP neighbors. Show IP EIGRP neighbors command um, displays the neighbor discovery by EIGRP. Go to the R1, enable. We type show IP EIGRP, EIGRP, NEIGHBOR, show IP EIGRP neighbors. And now this one is the R2's IP address by serial 0/0. Let's go to the topology. So R2's IP address so this is the 172.16.3.2. This is the R2's IP address on serial 0/0. And this is the 192.168.10.6. Then this is the R3's IP address on serial 0/1. So this is the R3's IP address on the serial 0/ and it is learned through serial 0/1. Now display EIGRP routing protocol parameters. Uh, what command displays the parameters and other information about the current state of any active IPv4 routing protocol process configured on the router? It is going to be show IP protocol command. We type show IP protocol. Now what we see here, we see that the routing protocol is EIGRP 1. So what routing protocol process configured on the router? So EIGRP 1 is the routing protocol, and EIGRP metric weight is bandwidth K1, load K2, and bandwidth K1 load and delay is K3, and reliability is K4, and MTU is K5, and maximum hop count is 100. So these are the composite metric value. Uh, default K1 and K2 are always 1. K1 and K3 are always 1, and K2, K4, and K5 are set to 0. So the result is that only bandwidth, which is K1, and delay, which is K3, values are used in computations of default composite metrics. The metric calculation method and EIGRP autonomous system must match between EIGRP neighbors to form an adjacency. If they do not match, the routers do not form an adjacency. Now, the default k value can be changed with metric voids router configuration mode command. You can see the um, composite metric formula used by EIGRP. This formula consists of K1 to K5, and this is also known as EIGRP metric weights. K1 and K3 are by you see the by default set to 1, and the rest other is 0. Load, reliability, they're all 0. Now, show interface command displays interface informations, and that includes parameters used to compute the EIGRP metric. It's a BW bandwidth of the interface. It's in kilobits. It is used in kilobit per second. And then delay is delay of the interface is in microsecond. And you have the reliability of interface as a fractions of 255. When it's fractional, when it's as a 255 over 255 is 100% reliability. Calculated as an exponential average over 5 minutes. Now, by default, the EIGRP does not include its value in the composite metric. Now, transmission load. Another two important factors here is receiving load and transmission load. Transmit and receive loads on the interface as a fraction of 255. You see over here is 1 over 255 transmission load, and receiving load is 1 over 255. When it's 255 over 255, it is completely saturated, and it is calculated as an exponential average over 5 minutes. Now let's go to the show running configurations of each routers to see is everything is okay. We do an R1 enable show run. We see that passive interface in gigabit 0/0. Network is 2.0, 3.0, and 10. So this one looks all right. Now let's go to the R2 enable show run. This is R2. Two dot 0, 3.0, 10.8. It looks okay. And now let's go to the R3. enable show run. All right, so um, in R3, um, this is the network 192.168.1.0, 10.4, and 10.8. Everything looks all right, but we did not, on R3, we didn't configure the passive interface and auto summary. So let's go to the R3. Config T router EIGRP 1 passive interface gigabit 0/0. Let me see which in the topology. This is the one that we are making it as a passive interface gigabit 0/0. And no auto summary. And copy run. Oh, so copy run start. Now verify end-to-end connectivity. PC1 and PC3 should now be able to ping each other. If not, troubleshoot. On the off screen, now I was trying to ping PC1 and a PC2, but I was unable to do that because on the off screen, I have found a mistake. That is, I was supposed to have 172.16 1.0. Instead, I put 172.16 2.0. So let's make a correction. Um, network, we first type, this is the one that we need to correct. Copy. So we're going to say no network. No network. Paste. No network 172.16 2.0. And then we type network 172.16 1.0 0.0.0.255 0.0.0.255. We hit enter. Now we did do show run. And we see that it has been corrected. 172.16 1.0, 172.16 1.0, 172.16 3.0, 3.0, and 192.10.4, 10.4. Then N, we do a copy, run, start. Now we ping PC1 to PC2. This is the PC1, PC2 address 172.16.2.0. Ping ping 172.16.2.2.10. We see the ping has been successful, and now we ping PC3 172.16.1.10. 172.16.1.10. No, 192.16.1.10. 192.16.1.10. And we ping from PC1 to PC3 192.168.1.10. Ping 192.168.1.10. And then ping is successful, so destination is reachable. Then you can see our completion rate is as 80/80.